Hello, everyone. Welcome to TestJS Summit 2021. And I'm Shivay, who's going to be presenting a topic on predictive testing in JavaScript with machine learning. So, a very quick introduction about myself. I'm Shivay, and I'm currently a TensorFlow.js working group member. I'm a Google Source Code mentor at TensorFlow. And by far, this is my third Git Nation conference talk this year. Previously, I've also given talk at Node.js conference and also React Advanced this year. So really excited to be presenting yet another talk at Git Nation, specifically at TestJS Summit. So without wasting any further time, let's get started. Now, first of all, machine learning is really everywhere today, right? There is no doubt in that particular fact. You can see machine learning being used in healthcare, education, but also when it comes to things within software development itself. Machine learning today is being used to do a lot of different things. For example, we have seen how GitHub Copilot is being used today to auto-generate or auto-suggest you code. It is also being used in ML ops, in different forms of operations in DevOps to improve the DevOps cycles. And that sort of makes it really important to also use it in other areas where we traditionally might not think that it might be able to be used. So that's what makes machine learning really powerful today. And that's why not just think about introducing machine learning to software testing. Software testing has traditionally been all about being able to write test cases, being able to sort of understand fundamentally within the entire software engineering life cycle that how can we actually make our softwares more and more productive and make them error-free. So what that means is that ideally what happens, or if you have a software tester or a QA analyst, they'll be going through the entire code and writing unit test cases. And of course, we have the entire pipeline of how the testing actually starts off, where first we write some code, then we prepare the unit tests, we have integration tests, and based on this, once if the test cases are passed and our code passes through all these different test cases from both the unit and the integration test, then we finally put our code into production. We also use things such as regression testing to be able to see how is new code actually impacting the code that has been written prior to, or let's say some of the older code bases, and how this code is actually getting affected. So all of these different processes involve basically either you can use manual testing, or we also have a lot of different automation testing tools as well, for example, like Selenium. And these traditionally haven't really used machine learning. It has been more to do with actually writing these test cases if you're doing manual testing, or even if you're using automation testing tools such as Selenium to be able to configure them so that they're able to go through your application. And generally, the software testing has not really seen a lot of use of AI, but this talk specifically will talk about how we can introduce and what are the benefits of actually adding machine learning or AI to software testing. So right off the bat, some of the great scenarios where AI could be actually used in testing. So the first one is the automated test cases generation. So a lot of time what happens is that we spend a lot of time in actually creating test cases. Now that could be behavior driven programming or behavior driven development, where we are actually creating the test cases before writing the code itself. Or let's say we have written a particular function and we write a unit test case for it. So how can we actually use AI to generate test cases on the fly by just evaluating the code, by going through the code, where an AI model just understands whatever code has been written, whatever code changes have been made to the code, and then automatically generate test cases without any manual intervention. Then essentially being able to find out that which particular tests to actually run that are more important, that will essentially save time and the sort of the entire process of the software testing time, where we are only running the most important test cases. I'll also be coming into more deeper discussion specifically on the second point, and then how we can actually use machine learning to not only test front-end based UI testing specifically on, let's say, JavaScript, but also how can we use machine learning to actually test out backend APIs. That's also one of the fields where today a lot of AI-based software testing tools are being worked on. And then how can we achieve 100% code coverage with the help of AI? Because code coverage is a really important topic to be used whenever we are evaluating any kind of a code base, whenever, let's say, we are creating a new build or we are testing out new deployments, new changes that have been made. If you're able to achieve even 90 or 95% code coverage, that itself is considered to be a really great point. But how can we achieve to close to 100% code coverage with the help of AI? And that is also something that AI can actually help with because of the fact that we are able to evaluate the code with the help of AI, and we are able to generate automated tests. We are able to run the most important tests that are really important for that particular code change. And that will actually help to just understand all the different nuances of the code that are there, including the code changes and how the new changes have actually impacted your older code. All of that can be considered while trying to do code coverage with the help of AI. And then even within the automation testing framework, how can we actually use AI, let's say with respect to Selenium, so that whenever you're doing any kind of an automated testing, AI can actually help improve it by looking specifically at the issues that might arise. And we are like using we are using basically automation testing to look specifically for those particular issues and try to be able to resolve them. So those are some of the scenarios today where AI is actually being used in software testing. So we do have a lot of different softwares that actually do use AI to do automated test generation, use machine learning to use better regression testing, use machine learning for better predictions with automation testing. And those solutions are actually going to be gradually going to be replacing even Selenium-based automation testing as well. And of course, the idea is now to be able to achieve code coverage that is 100% code coverage with the help of AI. And some of the benefits that actually AI will provide to software testing, first of all, it just helps us to save time. So whether it's actually being able to generate automated test cases, that itself is going to be saving a lot of time for the QAs who had to initially or earlier write the test cases. It just helps to expand the test or the testing scope. Now it's not just limited to be able to actually test just the incoming changes. Regression testing or changes that have been made to the code and how those have impacted the previous changes is also taken care with the help of relevant AI-based algorithms. And it just makes it a lot more user-friendly to use these auto-generated or auto-suggested test cases that have been provided by AI. And that actually just makes the overall process of the testing really simple and just widens the scope of being able to actually look out for such kind of test cases that humans or software testers might actually forget about. So it gives prevalence to those particular type of test cases as well. Now, let's actually have a closer look at how does traditional testing actually look like. So if we talk about regression testing, now regression testing will generally use whatever information that will be extracted from a build that we're creating. So whenever a build is created, we'll have certain metadata with it, and we'll be able to extract information from it to just understand, okay, like which particular test to run on some kind of a code change that actually has taken place. And by analyzing all those different kinds of information that has been provided or has been extracted from the build metadata, one can actually determine, okay, like which particular test to be actually run on the changed code, or whatever changed code has taken place, what all particular tests have to be run. And let's say one of the drawbacks of this particular testing suite would be that, let's say if you had to make a change to one of the low-level libraries, it would actually just become inefficient to just rerun all tests together. So for example, even for a smaller change, you might be required to rerun all of your test cases again and again. So that is where, and of course, this diagram sort of showcases the same, that you have your source files and you have your tests, and let's say if there are certain small changes happening, then based on those changes in particular library or in a particular network call or a particular function call that you're making, you'll be required to rerun those test cases again and again. And that's where basically we can use machine learning to do predictive testing. That essentially being able to find out what is the probability that, if you're trying out a particular test, right? How will it actually be able to find a regression within any kind of a code change that we're making? So how can we essentially make informed decisions to just rule out the tests that are not going to be helpful? So essentially being able to select those particular tests that really will matter for that particular code change, because of course not all test cases will behave or will be able to uncover issues within a particular code change. So be able to intelligently select those particular code changes that will result in actually making your testing process better and will actually make your testing process faster, because you're not just using all the different test cases to a particular code change. So essentially how can we achieve this is that we could use a large data set of that data set will basically contain tests on a lot of different historical code changes, and then by applying machine learning algorithms we'll be able to determine that which particular which particular tests are more well suited for particular type of code changes. And that will allow us to in the future, before the testing process actually takes place, or before once we have actually received the code changes, we'll be able to, before the testing process starts, we'll be able to select only those particular test cases that are more relevant for those particular types of code changes. And this sort of diagram showcases how we actually aim to get that. So during the training process, we have all of our historic code changes. So this can be considered as the database for being able to get these historic code changes, and then we are using our testing. And then basically we'll see that whether for every test it was a build, it was a failure or it was a pass, and then we'll be able to actually use it within our test selection model. And once we actually get started with the prediction, so whenever we have any kind of a new code changes, we'll basically use our test selection model to basically see which particular test might be actually useful for that particular specific code change, and that will enable us to save time. And to just specifically talk more about the training process, so we are going to be taking a model that basically just learns and the features that are derived, right? So when we're doing the feature engineering, it's essentially getting all of those from the previous code changes and tests that have run historically. And whenever we are applying this particular system to any kind of a new change, essentially the learn model will be able to be applied to that particular code change, and the model will be able to predict what's the likelihood of detecting a regression. And based on this particular estimate, we'll be able to select those particular tests that are more likely to cover that particular code change. So that's how we can save the amount of time that it might actually take to generate the code. So this can be directly used with any kind of a JavaScript-based testing framework as well, including things such as Jest, we have Jasmine, right? And of course, all the other different Mocha, right? So all of the different other testing frameworks can actually just use during the DevOps cycle when we are actually using, because this is not just actually limited to the front end of the backend coding, but essentially it comes under the umbrella of the test ops. So during the time when you're actually building or creating a build of your application, or creating basically, let's say, builds, and you're testing out the application to be deployed into production, that's essentially where you could use the predictive testing as well. And then, of course, even for JavaScript, of course, we can use this kind of a machine learning model-based system where we are, selecting the most appropriate tests. But even within JavaScript, we can have much better integration with the different testing frameworks that I just shared. And of course, we also have a lot of different unit actions, for example, by Polycode, that actually help for automated generation of unit test cases. And also, it is giving suggestions for unit test cases based on the code that it is able to evaluate. And there are readily available VS Code extensions for JavaScript, for TypeScript, where you can just use these directly from Polycode, and you'll be able to get suggestions and also actually just generate unit tests altogether. And We can also use automation testing improvements within Selenium that can also be used for JavaScript testing. And that's also one of the other ways in which you could actually introduce machine learning directly for JavaScript, like specifically for JavaScript-based testing. But frameworks such as Jest, Jasmine can easily benefit from not only the regression testing improvements, but also the unit test case generation, for example, that is supported by Polycode, to be actually used with these testing frameworks as well. With that in mind, that sort of brings an end to my talk. Of course, a lot of this is still under, more to do with the ML ops and with test ops, and we really just want to see how we can actually use these different kinds of solutions, specifically with a lot of the JavaScript-based testing frameworks. We're already seeing some of its use case right now available for use by a lot of different companies who are using AI-based tools to especially generate things such as automated tests, being able to do better code coverage, being able to intelligently find out which particular test to actually run to save time and make the regression process or the regression testing process better. And it's just a matter of time that when we're able to actually use these particular tools within our popular JavaScript testing frameworks as well. Of course, I mean, we already have some VS Code extensions and open source toolings that can actually generate JavaScript-based unit test cases, and you can use those suggestions in your code by just making the code be analyzed by these extensions or these frameworks, and that will just save a lot of time when you're actually doing software testing. And that's what really makes AI so powerful with respect to any kind of a field, and not just in software testing. So that's pretty much it for this particular talk. I hope that you liked and you understood some new concepts. If you still have any questions, I'll be here to take up any questions for the Q&A. And you can also connect with me later on my Twitter @hotdevelop or on my GitHub @Shivay Lamba. And that's it from my end at TestJS Summit. Thank you so much for watching. And I hope to see everyone in next year's TestJS Summit. Thank you so much.